Greetings, fellow scholars. Welcome to Scenario 4 of our Module 3 Excel report. For Scenario 4, we are going to be discussing simple interest and compound interest. We are going to use the absolute easiest scenario. We are going to borrow exactly $4 for this scenario. We're going to borrow $4 and see what that looks like with simple interest. When we're talking about borrowing $4, for this scenario, we're going to pay it back with 25% interest per day. So if we borrow $4 from somebody, let's say we're on the playground in 5th grade, and we have some 5th grader who's a math genius and tells his friends, hey, I'll loan you $4 for the concession stand, but you have to pay me back 25% interest every day. And let's say that this 5th grader is extra smart and this is on Friday, so now the person can't even pay them back till Monday when they're at school again. Maybe, I don't know. So let's see, we're going to borrow $4 and pay back 25% interest each day. Well, when we're talking about rewriting sentences into math equations, everybody loves to do that, right? Here I have to look for my interest is going to be 25% of whatever I borrowed. So when we're in math, we're looking at 25%. First of all, percents in math are not recorded as percent. We actually use the decimal form in mathematics. So taking the percent of something means out of 100, which means divided by 100. And when I divide a number by 100, the decimal place moves 2 places to the left. So that's what happens when we take the percent sign off. All right, and then we have of. The word of in mathematics means to multiply 25% of whatever I borrowed. And what we borrowed here was our $4. So what I borrowed, and then we're going to put that into this chart. I know this chart has too many numbers and it's going to make you dizzy, but let's see if we could break it down a little bit. I have day 1, 25% of what I borrowed. Day 2, 25% plus 25%. So 25% of what I borrowed plus 25% of what I borrowed. The first day, I think I forgot to mention right here, the 25% of what we borrowed was $1. 25% of 4 is $1. All right, so here we see that the first day we paid back an extra $1. The second day we accumulated $2 of interest. The third day, if we didn't pay it back the second day, then we have to pay it back on the third day, and now we've accumulated $3 of interest. In this particular scenario, the kid who borrowed the money may have to pay back $3 of interest. So when you guys can see that when I'm doing this day by day, adding up 25% of $4 plus 25% of $4 plus 25% of $4, and each day I have to add another 25% of $4, and I get all these $1 I have to keep adding up because our particular interest is $1 a day. Well, in mathematics, we love our formulas because in formulas, we always get to just plug in the numbers that we have. For this particular formula, we call this our simple interest formula, and it keeps us from having to add all these ones together here because, you know, this is a nice problem I made up, that $1 a day was something that made it easy to explain. But if it's not $1 a day, the interest can be very cumbersome to do all this math with. So we just take a formula, and in our formulas we have our principal amount. For our interest formulas, you'll always see the capital P will represent your principal amount that you either borrowed in this scenario or you invested. In this case, I guess the person lending the money is actually investing $4, aren't they? So we can really flip this around and look at it another way if we wanted to. Our rate is going to be the interest rate that is being charged or that we're paying. And then our time. Time is almost always recorded in years unless the units given in the scenario are different, which in this case, our units are days. In this particular scenario, our principal amount that we borrowed was $4 at a 25% interest rate. and our time is going to be recorded in the number of days. So let's see what our formula looks like. So now, rather than having all of this math to deal with, we get to just plug in our formula. So you can see that now the only thing changing here is my time, my days. So I have that 1, 2, 3, and then look what happens here on my 4th day. On the 4th day, I'm actually paying back exactly as much interest as what I borrowed. So what does that mean? If you pay back exactly as much as you borrowed, you're paying back twice as much, right? So let's go ahead and look at that. What does it mean to pay back money in simple interest? Well, if I borrow $4, then I have to pay back the $4 plus the interest. And you guys can see your formula here. $4 plus the interest. So I have my amount that I borrowed is all in green here. The principal amount that I borrowed is notated both in the amount, these 4 coins, that's this first P here, and then the second P is involved in the interest formula. So I have my interest and then my functions plus and of, and what my percentage rate, and then we can put this into a nice chart, and here we can see that our payback is going to be for the first day $1 extra, so a total of $5. My second day I pay back $6, $7, $8. So if you guys look here, you can see that on the 4th day we are actually paid back twice as much as we borrowed. So you want to be careful with interest. That was simple interest. Let's see what happens when we talk about compound interest. In this case, with compound interest, we're still going to borrow our $4 a day, and we're going to still keep our 25% interest, but this time we're going to compound it daily. So let's see what that means exactly. Borrowing $4 and pay back 25% interest compounded daily means, of all the stuff that this says over here, the most important thing is, well, I didn't put it on this particular slide, but we're paying back, let me see if I wrote it on the next one. Yes, here it is. This is what I wanted you to see. Right here, the most important thing for you to see is that when you're paying back compound interest means that you're actually paying interest on interest. So compound interest means that you're paying interest on the interest that you're accumulating. Let's see what that looks like. So here, the first thing, you guys can notice that the very first day stays the same. I pay back 25% of my $4, and then on the second day, I pay back 25% of my $5 because I have to pay back 25% of the $4 I initially borrowed plus the interest on that dollar. See, that dollar was the interest I had to pay over here. And then on the third day, I have to pay interest on the money that accumulated from the first 2 days' interests. So you guys can see how my increase is happening here. Instead of just doing 25% of my $4, now each day I have to calculate 25% of whatever that new amount is. And the amount highlighted is the new interest amount. All right, so you can clearly see here that the amounts are larger than they were when I was paying simple interest. I was just increasing by $1 a day. And when I get down to my compound interest, I'm actually increasing by a greater amount because I have to add the previous day's interest. So what does that mean when we're paying interest? On interest, it means we're paying back more money. So if you're investing money, you want that compounded interest so that your money can grow faster. But when you borrow money, of course, you want to stick with simple interest. So with compound interest, the big deal here is that you pay interest on interest. All right, so if you invest money in the bank. Let's say instead of borrowing that $4, you're actually going to invest some big amount of money in the bank. Well, the bank charges lenders to borrow that money, just like the interest that we looked at up there. The bank is charging people to borrow that money, and then what they do with your money that you invested is they give you back a piece of the pie. So if you look at this little thing that I've written here, see the bank, say you invested $4 into the bank. The bank turned around and loaned your money out. The way I have this set up, this would be for 50% interest. And then the bank keeps 25% of that and gives you the other 25. So that's how, and these are outrageous numbers. You're never going to get a 25% back from the bank, and no bank is going to charge 50% interest, I don't think, unless you're at the check cashing place, which we do have one in Hot Springs. Please do your best to stay clear of there. All right, so you put your money in the bank loans your money to other people, charges them money to borrow it, and then gives you back some of it. That's a real basic breakdown of a very simple banking investment. So we're going to move on to our Excel here in just a minute, and you guys can get a good look at this. We're going to be actually using these formulas in Excel. Aren't you thrilled that we do not have to do this by hand or with our TIs? We are going to, again, as always, let Excel do the work for us. So we're going to compare simple interest, compound interest, and then we're going to do something else called continuous compound interest. And we're going to look at the difference of these three things by building some really cool graphs and charts, of course, as always. And we're going to look at, here's just I thought this was a good visual. It shows you how the compound interest grows. Your simple interest is linear. It's kind of hard to tell that blue line is increasing related to the purple line. It's kind of hard to tell. And then the green is your investment. The investment does not change by itself unless it is gaining either simple or compound interest. Now, when we do our Excel scenario, at the very end, we're actually going to talk about student loans. What is a subsidized versus an unsubsidized student loan? We find that a lot of folks are taking student loans but don't know the difference here. So we're gonna get that figured out so you will know exactly what to ask for when you deal with your student loans. I'm not going to explain this chart because I feel like it's explained much better when we do it in Excel. I just wanted to show you that we're going to be looking at that. All right, so it looks like we are ready for our Excel, so let's go ahead and roll that out. I will see you guys here in just a minute. Until then, keep being amazing. You rock. All right, guys, here we are, the Excel portion of our scenario 4. We're really getting close, aren't we? All right, this one can go pretty quick because it's all formulas and dragging things around on Excel. So let's have a look at our instructions here. For scenario 4, we're going to do simple and compound interest. We're going to build some charts and graphs. For this first piece, we're going to assume that we have enough money in our bank account. We've saved enough money to keep ourselves afloat for 3 months, so our entire life can stay afloat for 3 months. We should all work toward that. It's not easy, I know, but little by little we can do it, making small sacrifices here and there. Now imagine that you have your bank account all set up so that you have 3 months worth of all the money you need to keep your life going comfortably, and you also did a side job and earned $3,600. And you say, well, I have everything I need right now for the next few months. I'm going to take this $3,600 and I'm going to invest it. We saw what happens when we invest money, right? So we're going to invest our $3,600. We're going to suppose that we invest the $3,600 into 2 different accounts. One's going to have a simple interest of 6% and the other a compound interest of 6%. I know we clearly already know which account we want to invest it in, but we're just going to kind of use this to explore a little bit. So we are going to create charts like so. So here you guys can pause the video and set up your charts. You guys have done some spectacular things with your charts, your graphs. Wow, I am just amazed at the stuff I didn't even know Excel can do. And I'm looking at your guys' Excel and thinking, wow. So I've tried to do a few things for my school on some of my reports I have to do to make it look nicer. So as always, I learned so much from you guys. Thank you. Keep it up. All right. So things get easy here once we have formulas in math. I want to show you our simple interest formula here. You guys can see where it says the outcome. That's what the A means. It means the amount that we expect to get or to pay. So here I have that amount is going to be the principal times 1 plus the rate times the time. So let's just take a really quick look at that here. I made a little PowerPoint thing. Let's just see real quick what that looks like. If I can find where I made it. Here we go. So here, you guys remember that we did, when I pay something back, I pay back the principal plus the interest. And that's all this is. I have the principal plus the interest. You guys remember factoring? I know you try to suppress those memories. I know that. So what we did here is we factored out the P. So both of these formulas mean exactly the same thing. You can use either one. I just wanted you to see that it's written different ways. Now what happens if we multiply that P back in? P times 1 is P, and then P times RT is PRT. So we actually end up, once we distribute that P back in, the principal, we get that same formula back. So I just wanted to show you guys that. It was the same formula that we've been looking at. So let's go back and look at what we're doing here. We had some initial investment, so that was going to be our $3,600. And then we had an interest rate. You guys had some interest rate. I'm going to use a different interest rate. You guys had a 6% interest rate. I'm going to go ahead and have an 8% interest rate. And I have already put percent in here, so I did not need to double click in my cell, just single click. You guys should have all this labeled. I've already gone through and done it. So just remember, click in here, go up, don't click the dollar sign, or it will do some crazy accounting stuff. Click the drop down menu to English United States dollars, and then on your percentage here, click your percent. Don't forget that if you put the percentage in first, you have to put 0.08. And then you can change that to the regular percent, okay? If you put in 8%, if you put in 8 and change that to percent, it will give you 800. So remember little things like that in math. That percent sign is a language symbol. If you get a real calculator, a graphing calculator, scientific calculator, you will not find a percentage sign anywhere in any program in that calculator. There will be no key with a percentage sign. If you don't believe me, go get your calculator and look. Sometimes if you buy one of those little El Cheapo calculators, it'll be on there, because common people know how to use percent, so they do that. But on a scientific graphing calculator, you will not find a percent symbol unless somebody has uploaded a special program into your calculator. You still won't find it on a button, on a key. All right, so our time. I just typed in the word time here because our time is actually going to be, you know, we're going to grab all these different years, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have the number of times that when we do the compounding, the number of times that it's going to be compounded per year. Well, if you look here, it says that we are going to make these charts, create a chart to record the values for the variables. And we're going to use the World Wide Web to find out what those variables mean. I've already got them listed, so I'm sure you guys can just look at mine. But it is good to search the web for those things. We're going to create a chart with a column for the years, rows 0 to 10. You can see that I have that over here on the right in green, if you can see colors. And then we have a 6% simple interest, and then we're going to do a 6%, this is what I'm trying to get to right here, quarterly compound interest. Quarterly compound interest. Well, if I come back over here to my formulas, my compound interest is N. N wants to know how many times a year it's compounded. Well, quarterly means what? 4, right? So every 3 months, my interest is going to compound. So it's compounded quarterly. So I put a 4 there. All right, I'm getting a little, I always get dizzy when I have this too big because I can't see everything I'm doing at once, but I know you guys like it to be like that. All right, now I can use my formulas. In math, we have formulas. We say plug and chug. Just plug in the values and let the formula do the rest. So I have to wear my glasses. I have my equal sign, of course, to tell Excel I want to do math. My principal times, open parenthesis, 1 plus my rate times my time. And close my parentheses. If Excel wants me to close it, FIR says just hit enter twice. So there we go. Hit enter again, that'll go away. Thanks, FIR. I did not know that. So now I'm all good to go. I can just double click and my formula. Whoa, what happened here? I got all these crazy numbers. What happened? Well, hopefully you guys are out there mentally screaming, hey, Benzie, you did not lock your cells, right? Because what's happening here? What happens when I get to this one? Well, it's easier to see if I come all the way down here. See how it's grabbing the proximities? I had initially grabbed my principal and my rate, so it's grabbing it all the way down. And what do I need to do? Hopefully you remember that these cells need to be locked in. So you just put a $ around each of your letters. Remember that your last one is your time, and you do actually want that one to change, so you're not going to lock that one in. And there we go. That makes sense. At 0 years, I have $3,600. So you'll have that number too, but all of your other numbers will be different, don't forget, because, and if you guys, you know, if you do all the same stuff I do, and then you just come back right here and change this to, I'm going to change it to 3. It will change all your numbers. So you can follow right along with me, everything I'm doing, and then at the end, just come in and change your interest rate to be correct. And that way you can check all of your numbers and see that yours are all correct. And then it's a good way to see how amazing these formulas are in Excel and these cell references, the way they pivot back and forth to each other. All right, let's move on to our compound. Equal, again, guys, plug and chug. I have my principal times my rate divided by n, the number of times it's going to be compounded. And then all of that is going to be raised. Let's see what all gets raised. And I have something missing here. Hopefully you guys saw that. That's 1 plus. All right, so 1 plus rate divided by compound times, all of that is raised to the power of, and I'm going to use parentheses. I did not put parentheses in the formula, but I overuse my parentheses because it makes me feel safe. Pretty good if you feel so safe that the next thing you need to feel safe is having parentheses, right? All right, so the number of times my year, and my year is my green column there. All right, now I need to figure out what all stuff do I not want to move. Well, I don't want anything to move except my time. So I am going to lock all of these cells in. We're going to talk about perspective on the last scenario, and I just thought of perspective right now. And I'm excited about the last scenario. That's why I mentioned that. It's going to be fun. You guys are going to like it. It's short and quick, okay? All right, so my quarterly compound interest. Let's see. Boom, there it is. Excellent. Now what about my continuous? Again, folks, plug and chug. And you know how to use E. We've used it before. I have my principal times EXP, exponent, raised to the power of, but I don't have to raise it to the power because that's what EXP already means. I'm going to take that E value and raise it to the power of the rate times the time. And I got an extra thing in there. All right, very good. And then again, the only cell reference I am not going to lock is the time. Everything else gets locked up or we get a disaster like you've already seen. All right, and something went wrong here. I'm not sure what it is. I'm going to pause the video to find it. Do you guys see what it is? Instead of actually clicking on the time like I was supposed to, I clicked on my time all the way over here. I'm sure somebody caught that. Why didn't anybody tell me? All right, there we go. And voila. Gotta love it. Love Excel. It is spectacular. I'll just tell you guys, Abaza, she's one of our graphic design artists, and she is one of you that are doing some amazing things with Excel, and you guys should do what she's doing. We discussed her putting it on her resume as a data artist, and everything that you guys are learning in this class, if you're in graphic design, can you imagine if you had a business and somebody said, hey, give me your data and I can create beautiful charts and graphs for all of your data. You guys can do this. And Abaza, that stuff you're doing is unbelievable, beautiful. Many of you guys are doing some really good stuff. I don't even want to start mentioning names because I would never stop. You guys are just rocking it. Very good. All right, so let's keep rolling here. I am going to select all of this data. I am going to insert a smooth line graph. Make sure you guys label all of your graphs and charts. Some of you learned that when you don't label your graphs and charts, if no charts are labeled, that's 60 points according to the rubric. So 60 points can really add up. So make sure that all of your axes are labeled and your titles are labeled. But most of you do a spectacular job at that. All right, so here we are. Now, the instructions say to change, to insert this chart. The instructions tell us to do a couple of things here. First of all, I guess I'll go back here and show you guys. I just remember. All right, first of all, we are going to start our y-axis at $3,500. And then we're going to use a scale of 200. So here, remember on our Bill Clinton, George Bush unemployment rate graph, how we wanted that graph did not start at 0, but we wanted it to start at 0 to show the true difference. When it did not start at 0, it exaggerated, highlighted the difference. And that's now we actually want to highlight the difference because we want to clearly see the difference between compound interest and not compound, what's it called? Simple interest, sorry. All right, so I'm going to change my minimum value over here to 3,500. I am going to change my major to 200. I don't know, 500 looks pretty good, but we said 200, so we're going to leave it there. The graph got awful busy at 200. You guys can go ahead and leave it at 500 if you want to. It just, I don't know. I'll just leave it at 2 since I put it in the instructions. Did I leave it at 2? We'll just do it. There may be a reason that I did it and I just don't remember what the reason was. I don't know. All right, so here we have our axes. Now, the other thing that it says in the instructions is to change your quarterly, I don't know where it says it, but it says to change the quarterly interest to annual interest. Yes, right here. It says, create a scatter plot with smooth lines for the set of data, but change the quarterly compound to annual compound. Well, what does that mean? It means right over here. See where it says number of times per year that it's compounded? Instead of 4 times a year, we only want it to show once a year. Because what happened now, it gave me just a little bit more separation so that I could see the graph better. And you guys, if you do this on your actual report, a lot of you love to have interactive things going on while you're giving your report. Man, I love that. If you do something like that, then you can just click back and forth here, you see, and you can talk about, you know, there wasn't really that much difference. When I compounded 4 times a year, it was extremely close to continuous compounding. But when I only compounded once a year, it was a noticeable difference between an annual compound and a continuous compound. So that's pretty good. And you guys can Google continuous compound and get some more details to explain that in your report. All right, I think we're done with that piece, guys. Let's go ahead and move on to the next piece. Again, plug and chug, plug and chug. We love formulas in math. So let's see what we're going to be doing for part 2 of this scenario. We are going to, I think we're going to buy a house. Let's see if I remember correctly. Oh, and you know, you guys had to do this thing, you know, I did 8%, yours is 6%, but look what happens here. If I put in a 3 again, everything changes, everything. So once, if you guys do Excel properly, you know, especially if you use it for your homework, you get a homework problem wrong and you have to redo it. No big deal. If you used Excel, you just type the numbers in. All right, let's get on with our house purchasing here. We are going to, now that we understand simple and compound interest, we're going to see how we looked at how it works for investments, and now we're going to see how it works on a loan. So we're going to suppose that we buy a home for $120,000. We're going to put 8% down on that house and then pay 5% interest. I am going to change my amount down. I have to change something, so I'll just change my amount down. We're going to create a chart to record the values for the variables needed for the monthly payment formula, which is right here on the right. And we're going to use the World Wide Web to find the meaning of these variables, which I have them listed, so you guys can probably just use mine if I didn't already say that. And then we're going to create a chart here. Our chart is going to have our years labeled from 5 to 35, and then we're going to calculate our monthly payment, annual payment, total, and interest. And then we're going to come down here. I'll just explain it to you guys instead of reading all that. Then we're going to come down here and we are going to decide if we buy this house, what happens if we make an extra $50 a month payment? What happens if we pay one extra $100 a month? So we're going to actually explore that. All right, let's go ahead and get started. The cost of my house was $120 grand. My down payment was, what was it, like 8%, I think. I'm going to go ahead and use 6% down payment. So my down payment here is 6%, and I've already got my, you know, my things in a dollar, in a percent. So you guys will just do that too. You know how to by now. All right, and if you don't remember, it's just right up here on this little number thing. All right, what is my down payment? Well, my down payment is 6% of the cost of the house. So remember 6%, remember what of means, multiply the cost of the house. So I paid $7,200 down. Now what's my principal amount? How much am I going to borrow? Am I going to borrow $120,000? No. Well, maybe. You might be able to borrow $120,000 and you can use that extra money to fix something up. I don't know. So here we have our principal amount that we're going to borrow is the cost of the house for this scenario minus our down payment, right? Isn't that how much we're going to borrow? And then our rate, what was our rate on this house? I'm going to use the same rate, so you guys only have to change one thing. And our rate here was 5%. So we have a 5% rate. All right, now I'm ready to plug and chug. Here's my formula. I need my principal. Oh, look, I almost selected the cost of the house. Be careful, you guys. Remember, the principal is the amount we borrowed, and we paid a down payment, so we didn't borrow that whole amount. So also don't forget to put all of the parentheses that I have. All right. Oh, there I did it again. The principal amount times the rate divided by the number of payments per year. Well, how many payments per year do we make on a house usually? Don't we usually pay monthly? So, you know, you might have some weird thing where you pay quarterly or something, but not usually. It's usually monthly. So that number will be 12. We're going to all make that number 12. All right. And then we are going to, that's our entire numerator. So I want you guys to notice how the entire numerator is in parentheses, and then the fraction is in its own little set of parentheses, divided by my denominator. I'm going to put my denominator in parentheses. I have 1 minus, and then I have another little section of my denominator. So I did open parentheses, 1 plus, open parentheses, because I'm dealing with a fraction, my rate divided by, again, how many payments am I going to make? 12 payments per year. And then I am going to raise that. Notice it's 1 plus that fraction, all getting raised to the power of, sometimes Excel will just accept a negative sign, sometimes it won't, but it always accepts a -1. So I'm just going to go ahead and put times -1. And I'm adding extra parentheses. The parentheses, like I said, they just make me feel safe. So I have -1 times n, which we said was 12, times t, which is our time, which is right over here. Close parentheses. Now, let's think about this before we go on. We can end up with a disaster. We are just going to lock in all of our cells except our t. We want the time to stay the same. So I am locking everything in except my Hotel 32. And your guys's will likely be something different. All right, hit enter. Let's see. All right, something's wrong. I'm going to pause the video and see if I can find it. Okay. So I even said this, is that this 1 plus all of this that I just highlighted is supposed to be raised to the power that I have all over here. But what happened is I didn't close this last parenthesis. So the only thing getting raised to the power is this little fraction. So I have to close this parenthesis here to get all of that in there. So now I should be able to close one of those. So just check your parentheses, check them all. I have an extra set of parentheses down here that I did not have up here. So let's see what happens. I think that's going to be correct. And it looks like I should have put some more parentheses up here too. What did we have? 3 sets down here? Yes. All right, very good, very good. Lots of parentheses. All right, there we go, folks. So now we need to figure out our annual payment. Well, what does annual mean? It means per year. How many months are in a year? Well, that's going to be 12 months times my monthly payment. That's how much I'll pay each year, right? So now, I already put this chart. Look how I had the chart over here and I deleted all my stuff, but I must have forgot to delete that chart and that went away when the numbers, but you see it's growing back now. That's kind of cool. Actually, that's pretty cool. I can select all my empty blank data and create a chart and then let it fill up as I go. That's kind of cool. I guess I'll just kind of go with that. All right, so here's our total here. The total is what? Well, we have our annual payment. This is how much I paid every year times the number of years that I paid. which is over here in this column with years. So I hit enter, and now I have all of those amounts. I'm not sure what my graph is doing over there. I'm just watching it for fun, and I'll go back and insert a new one at the end just to see what happens. All right, but I've never worked a graph backwards like this before, so it's kind of cool. All right, so my interest rate, what's my interest rate? It is going to be the total amount that I paid minus my principal. Don't forget, it's not minus the cost of the whole house, because we did not borrow $120,000. We borrowed $112,800. So the total amount I paid with all my monthly payments minus the principal that I borrowed gives me the amount of interest that I paid. All right, so there's that amount. So I'm sorry, I'm just looking at this graph over here because it just doesn't look right. I'm going to go ahead and delete it. I'm not really sure if it's correct. It just looks kind of odd. It seems like my interest should not be higher than my total amount. So I'm going to go ahead and delete that. All right, I did have some trouble when I labeled my years inside of this peach cell right here. It gave me a little trouble. So I left that blank, and then it worked for me. So I am going to go ahead and select all of this data and insert a 3D column graph. All right, I'm going to pause the video and see, it just doesn't seem right that my total is not more than my interest. So that's concerning me, because my interest is supposed to be this column over here. So my interest should be $1,400, where my total is $127. Oh, wow. Do you guys see that? No wonder I was confused. It's so, it's crazy. Look at this. So $1,400 is how much interest I pay if I pay my house off in 5 years. And that is over here on the very left-hand side. Okay, I did have to stop and look at it better. So I totally see what's wrong. I'm sorry, you guys. Hopefully you have figured this out way before me, but I didn't lock my cells. So it's been selecting all the way going down where there are no values. So I'm going to come back up here, lock my cells. I got so excited about that graph building as I was putting the numbers in that I completely lost track of what was going on here. All right, so let's see. I locked in a cell I was not supposed to lock in now. And it is because my interest, my total amount does need to change. I want that to go down with them. All right, there we go. That looks much better. So here you can see that my total is changing, but my principal amount is not. Okay, good, you guys. So this looks more like it's supposed to look. Now we can see from our chart here that if we pay our house off, yikes, that got a little too big. If we pay our house off in 5 years, see this yellow block? If you can see colors, I know some of you can't see colors, but the block farthest on the back, that's how much interest we pay. And the gray amount, this second to the last, is how much we pay total for the house. So I pay, in 5 years, I would pay a total of $127,000. Well, the house was worth $120,000, so I only paid $7,000 to borrow that money. But, you know, what was our monthly payment there? The monthly payment was $2,100. Who can afford that, right? If you can afford that, you know, and some people can afford it at some times and then later on can't. So while you can afford it, you know, pay it. We're going to look at that in a minute, what that does. All right, so now we have, if we pay the house off, let's just go all the way to the extreme. If we pay the house off in 35 years, I got this little highlighter over here. Boy, I'll tell you, I really struggle with making these Excels big so that we can talk about them. All right, so if you look all the way over here at 35 years, how much interest did we pay? Holy smokes. We paid $126,000 interest. That's $6,000 more than the house was even worth in the first place, just because we wanted that low monthly payment of $569. So you can see how the graph changes. And besides that, look how much you ended up paying for the house in the end. $239 grand. That's practically twice as much as it was worth. So you wait longer, you get that lower monthly payment, but in the long run, you pay a lot of interest and you pay a lot more for your house. So keep all that in mind. Now, let's talk about, what if we went with a 20-year loan? A lot of people, a lot of banks really like a 20-year loan on a house. So let's go ahead and just look at this 20-year spot on this loan. And we are going to look, we're going to fill this little chart in down here and talk about basically what we just did. What happens if I pay $0 extra money a month? And then we're going to say, okay, what happens if I pay an extra $50 a month? And then what's going to happen if I pay an extra $100 a month? So we're actually going to explore all of this. Your instructions on your page give you a web link to follow. So we're going to go ahead and follow that link and put our data in to this little chart. And I've already done mine. Mine's even still a different number than what we have here. So, sorry, I have to make it small. I'm going to have to figure out some way to make these big for you guys and then also make it workable for me. I have my principal amount here, 112,800. All right, my original loan amount, the initial term of the loan, well, it says right here in months. So, and you can click on any of these little question marks and it'll tell you, you know, anything that you guys need to know there. And we have our months and then our interest rate. I used, sorry, I'm probably making you dizzy with all this back and forth. Where is it? Our interest rate was 8%, right? No, our interest rate was 5%. Okay, so then extra payment, it doesn't let you put 0, so I just put 1 because that'll get us close enough to 0. And then we are going to say we've only made 1 payment so far. And this is, and you guys can put this in here for any of your amounts. Change it. See, check out for yourself how much you can save. This is an amazing tool. All right, so look, even if I just paid $1 a month after 20 years, I would save almost, I don't know what, 170 bucks. In 20 years, I would save 170 bucks if I just paid an extra $1 a month. So I know that's not too much, but hey, 170 bucks is 170 bucks, right? So what happens now is we put our information in here. All the information that it gives us on this web page goes into our Excel. So it says, I think I'm going to lose this if I click on my Excel. All right, at 0, and you know, like I said, we just put 1, so it's not much of a difference. So we're just going to call it 0, okay? So 0 monthly, 0 extra dollars every month gives us a monthly payment of $744. Okay, and look, what did it give us up here on our chart with our formula? 744. So that's pretty darn close. How many months until we pay it off? 239. And I'm getting, you can't see where I'm pointing to. I'm getting this data from the web page over here. Hopefully you can see that. The total amount that I paid for the house, I am going to collect that information by my monthly payments. So I'm going to put an equal sign in here. My monthly payments times the number of months that I paid. That's the total amount. And then my interest rate is going to be the total amount I paid minus the amount I borrowed. Okay? Now, now we come back over here to our calculator, and we are going to put in new information. The only new information we're going to put in is our extra monthly payment is going to change from 1 to 50. I'm going to pay an extra 50 bucks a month. Let's see what happens. All right, at an extra 50 bucks a month, my payment went up to $794. So this goes to $794. My payment's $50 more. And then my months until payoff are 215. So now I'm paying it off earlier. The total that I'm going to pay is going to be, well, these two things I can just drag down now, and I can drag it all the way down. All right, so cool. Now, oh, and of course, I am the forget to lock stuff in queen today. I did not lock in my principal amount, and if I want to drag things around, I have to do that. All right, so now I can see that I'm only going to pay $5,700 in interest, and I'm going to just pay $7,000 less in the long run. So that's a pretty good difference. Let's see what happens if I pay an extra $100 a month. And you guys can see that the months till payoff, you can check your own house and see how many months you have to pay off and how much money you would save with the time you had left. So I hope you guys use this calculator for you that are homeowners, and for those of you who can show your parents, you know, tell your parents, hey, I'll give you an extra $5 a month for rent, and in the end you give me what I saved you. You know, in 10 years you could get a check for 700 bucks and you'd be like, oh, where'd this 700 bucks come from? And your parents will say, oh, well, remember when you gave us $5 a month? I know, it's crazy, but it could happen. All right, so $100 a month, we are going to end up with $844 a month payments. Our months until we pay off are 195. See, the more money you give your parents toward their house, the sooner you will get it back. Wow, look at how much money we saved. Wow. So we saved, what is that, like $13,000, even more than that, $13,300, if I'm doing my math correctly that quick in my head. And the interest, how much less interest we've paid? A lot. So you guys can really see a huge difference if you just pay a little extra each month on your, you know, this is just a house, but this is for a car, or, you know, if you're Johnson, you're riding that nice motorcycle. And if you guys pay a little bit extra on whatever it is you own, you can really make a big difference. Let's see exactly how much of a difference we can make. I am going to grab all of this data. I don't know if I can I use all of these cells? I think I can. And I am going to insert a 3D column chart. So let's see, monthly payment. Oh, okay, so I've got more stuff than I want here. I want my, hold on, let me pause this and make sure what I have going here. Okay, I see why this one doesn't look like the one I did earlier. It's because these months until payoff, I do not want that in my chart. So I am going to select this set of data, unclick my mouse, hold my control key down, and then come back and select the other two columns. And then I am going to insert my 3D. There it is. That's what I'm looking for. All right, so now we have a chart. Please, guys, don't forget to label everything. This one gets really cluttered, but it's important that we can see all of this stuff. So just make the graph bigger. And now what we're going to do is we are going to pull apart each of these pieces. So we're going to look at just our monthly payments, and I am going to insert a 3D chart just for that, just the same kind of chart. So there are our monthly payments. You can see that if I pay zero amount, I have a lower monthly payment, and if I pay an extra $100, my monthly payment increases, of course. And then we also are going to look at our months till payoff. And again, you guys, I just select with my mouse, I select that column, let go, hold the control key, and then select the next column. Well, this one I didn't need to do that, but that's how I'll do the others. Oh yeah, I am doing that. Sorry, I'm a mess. All right, so highlight, hold down control, and then go to total paid. And then insert a 3D bar graph, the 3D column chart. All right, now look at this, you guys. This is, I just really want you guys to see this. I know it's all perfectly noticeable on this chart where we did everything at once over here. This chart where we did everything all together. But you can't really tell the monthly payments are so tiny. And if you guys think about those monthly payments, think about how you have to stack those monthly payments up to reach your total paid. But look at your total paid here, you guys. You know, you pay a lot less. This amount down here on the right is the total amount that you paid relative to if you paid nothing extra. So there are all kinds of ways that it benefits you to pay that little bit of extra. All right, let's take a look at our last one here at interest. And we are going to insert that 3D column chart again. Right here. Oh, looks like I've gotten into this. That's fine, just move it. All right, so here now we have a graph to show our interest. And I am also going to, let's see, I guess I did do a graph for this one too. So we can insert a 3D column chart for that one as well. Just so that we can see our months until payoff. It was senseless to put the months till payoff onto the big chart because it was, you know, just like the monthly payments. So the months till payoff, you can see that you pay less months when you pay your extra money. So you guys, please explore that, have some fun looking at it. Hopefully this is something that can help you help others as well. We have one more scenario, or not one more scenario, but one more part to this scenario. So let's go ahead and knock it out. And again, it's just a plug and chug with the formulas. So let's see what we're going to be doing. Oh, and of course, I just want to show you guys really quick is that the one thing I had different is you guys had 8% down, I had 6% down. But what happens after you do all of this with my 6, don't forget to go back and change that with your 8. And I'm just going to put 10 in here just to show you. Everything changes. So you guys make sure that you put your correct value in there. Okay? Excellent work. Alrighty, so, oh, this will be fun. Now, if somebody has the wrong numbers, I can go back and check and see if they paused my video at 6 or 10 to copy all my numbers. All right, let's look. I know no one's going to do that this time, right? So we are now going to have a look at subsidized and unsubsidized student loans. What is a subsidized loan and what is an unsubsidized loan, and which one do I want? Well, that's what we're fixing to find out, folks. We're going to see if we can clarify the outcomes of subsidized and unsubsidized loans, student loans. Suppose you acquire a loan of $12,000. This is I Googled it. This was about the average amount that a person earning a 4-year degree ends up borrowing. And the loan is going to come to us at a 3.5% interest, and we have to begin making payments 3 years after we take the loan out. And you'll see what all this means as we move along. We're going to create a chart with the types of loans, and then we're going to create 3D columns to show the principal, monthly payments, and total payback for each of the loans. And then we're going to go to this site right here, and we are going to check our calculations. So you guys can go to that site and check your calculations. And also, I'm not going to actually go to the site. I want you guys to do that. And also look at other loan options on that site. All right, here we are, folks. Of course, this has got to be bigger, even for me. So again, I have my formula pasted here. I have what the variables represent are supposed to be on there as well. Our unsubsidized loan, how much did we say we were borrowing? I think it was 12 grand. 12,000 at 3.5. All right, so my principal here is 12 grand. Just make your column a little wider if that happens. And then my rate was 3.5. I'm going to go ahead and put 5.5. Hopefully you never get a rate for 5.5. And then years till graduation. This is going to be 3. Sorry, we're going to put 4. Let's say we took this loan when we started school. So we still have 4 years till graduation. 3 is the amount of time we'll have to pay it back, and that's going to come to play here in just a minute. All right, our total monthly payments for this loan. Well, our monthly payments are the exact same formula that we used above. So I am actually going to work hard, not smart. You know what I mean. I'm going to work hard, not smart. How's that? I hope that I can avoid doing that in my life. I am going to work smart, not hard. And I just went up and copied my formula. It's all ready now. All I have to do is click on the different values. Here I have my principal, and then my rate. We are going to stick with our monthly payments of 12. And then what was this value? This was also our rate. And then this was our time. And this is going to be different in time. So for this particular formula, we're always, the typical student loan is for 10 years. So we typically take a student loan for 10 years. So our monthly payments in this case for our N, the number of payments, is going to be 120. And we're just going to leave that at 120. Even though the formula says different, the formula says the number of years, but we're just going to assume it's 10. Okay? So we have N is the number of payments, and then T is going to be 10. I'm sorry, I'm getting ahead of myself. 12 times 10 is 120. I'm already just doing the math in my head. All right. So now we have our monthly payment. So this is the monthly payment on our subsidized loan. And then for the total amount that we're going to pay back, we are going to look at, we have 10 years, 10 years times 12 months. You could have just put 120 there. 10 years times 12 months, times our monthly payments. All right, so we are going to pay $130 every month for 10 years, and our total payback is going to be, I left out the 12 here, $15,360. All right, so now let's look at what happens if I have an unsubsidized loan. Now, when you guys were dealing with this subsidized loan, what happened was there was no interest accumulating for those 4 years that you were in school. So those 4 years that you were in school, you did not have to pay any money on your loan. But what happens over here when you have an unsubsidized loan? Oh, and then also that 10-year payback time starts the day you graduate. Student loans, you don't pay student loans while you're in school. You can, most people don't. We're in school, right? So how can we really make enough money to pay back a loan while we're in school? Although many people do, both. So if you take an unsubsidized loan, what does that mean? Well, it means this. It means that you took your $12,000 loan plus you paid the interest on that loan. So now you not only took the big P, the $12,000, you also borrowed the interest rate that accumulated during those first 3 years or 4 years. So now you have your principal, and then you have to add again your principal times your rate times the 4 years. So now look, you're actually borrowing $14,000 because you did not get a subsidized loan. So now that means you had to pay the interest while you were still in school. So that means our rate stays the same, our years till graduation stay the same, and our monthly payments are going to change. And let's see what happens here. I'm going to drag this down. There we are. So what did we have here? This was times, oh, I see, this turned into a bit of a mess, didn't it? All right, so you guys see this? I had the 10 years times 12 payments per year times the amount of the payment. All right, and then I did the same thing for this one. I did the 10 years times 12 months, that's 12 months in a year, times the amount of the monthly payment. So I'm actually paying back a good amount, over $3,000 more by getting the unsubsidized loan. So watch those loans, you guys. Make sure you know what you're doing when you take out a loan. Let's see what else we have left on here. It looks like we're ready to answer our questions. You guys, everything was explained during the course of the video. So I am looking forward to, let's just get one quick look at everything here. Were we supposed to have a graph for this one? Yes, of course. So I'm actually not finished yet. I'm just going to select that data and insert again the 3D bar chart. And there it is. Is that what I wanted? I just wanted the principal, monthly payments, and total payback. So let's do that again. Principal, monthly payments, and total payback. Those are just the columns that I want. Hopefully you guys can see it. And then insert my 3D bar graph. And there we have it. Make sure, of course, that you guys title everything. That's kind of weird, isn't it? I don't know where that little thing came from. So make sure you guys put a title. Well, I'm having some technical issues, obviously. My little graph chart has moved. All right, so you guys can clearly see. Let's just take one quick look at our subsidized and unsubsidized loans again. You guys can see that your principal is actually changes because of the way the interest accumulated for those 4 years in an unsubsidized loan. So your principal amount is higher, your total payback is higher, and it's hard to tell, but your monthly payments are also higher, which you would be able to see if you pulled those out separately. All right, you guys, here is scenario 4 all out on one sheet. This is about what it looks like. All right, so I will see you guys in scenario 5's video. Until then, keep being amazing. You rock.